Hello, everyone. Welcome to the last class video, the homework review for sections 5.4 and 5.5. In the first very many examples, the directions are simply to perform the indicated unit conversion. In number 1, we want to convert 20.5 ounces to pounds. So we have to use a conversion factor with pounds on top and ounces on the bottom to cancel away ounces and leave us with pounds. That's going to be 1 pound over 16 ounces. 21.5 times 1 divided by 16 gives us 1.34375 pounds. In number 2, we want to convert 0.75 hours to seconds. So we'll start by converting hours to minutes and then minutes to seconds. Getting rid of hours requires hours to be on the bottom. So 60 minutes on top, 1 hour on the bottom. And then getting rid of minutes and leaving us with seconds requires minutes on the bottom and seconds on top. The math, 0.75 times 60 divided by 1 times 60 divided by 1 gives us 2,700, and the units we're left with are seconds. In number 3, we want to convert 21.5 ounces to cups. This is going to require cups on the top and ounces on the bottom to cancel ounces away. That conversion factor would be 1 cup over 8 ounces. So the math, 21.5 times 1 divided by 8 gives us 2.6875 cups. In number 4, we want to convert 9.75 pounds to pounds and ounces. So the 9 part of the 9.75 pounds is already our pounds. We just need to convert the 0.75 pounds to ounces. So that requires a conversion factor with pounds on the bottom to cancel pounds away. Ounces on top, that's going to be 16 ounces over 1 pound. Doing the math, 0.75 times 16 divided by 1 gives us 12. And the units we were left with was ounces. So taking the 9 pounds that we already had, this would be 9 pounds, 12 ounces. In number 5, we want to convert 7.2 minutes to minutes and seconds. Similar to the last problem, the 7 part of 7.2 is already in minutes. So we just need to convert the 0.2 minutes to seconds. This is going to require a conversion factor with minutes on the bottom to cancel minutes away, seconds on top. That would be 60 seconds over 1 minute. The math then is 0.2 times 60 divided by 1, and that gives us 12. The units we were left with were seconds. Bringing the 7 minutes we already had into it, we get 7 minutes, 12 seconds. Number 6, we're starting with 3 hours and 12 minutes, and we want to convert to decimal hours. So the 3 hours part of it is already in hours. We just need to convert the 12 minutes into hours. That's going to require a conversion factor with minutes on the bottom to cancel minutes away, hours on top to get us hours. That's going to be 1 hour over 60 minutes. The math then, 12 times 1 divided by 60 gives us 0.2 hours. Bringing the 3 hours we already had into it, we get 3.2 hours. Number 7, 5 pounds, 6 ounces to decimal pounds. Once again, the 5 pounds part of it is already in pounds, so we just need to convert the 6 ounces into pounds. That's going to require a conversion factor with ounces on the bottom to cancel away ounces, pounds on the top to get us into pounds. That's going to be 1 pound over 16 ounces. So multiplying and dividing, 6 times 1 divided by 16 gives us 0.375 pounds. Bringing the 5 pounds we already had into it, we get 5.375 pounds. Number 8. We want to convert 1 1/4 cups of water to pounds. We're going to need a couple of conversion factors here. We know that a pint's a pound the world around. So we have our conversion factor of 1 pound is to 1 pint. In order to use that, though, we would need our answer in pints. So we need a conversion factor involving pints and cups. We have that. It's 1 pint to 2 cups. Making sure things are in the right place, we need to start by getting rid of cups. So cups has to be on the bottom. That leaves us with pints because pints is going to be on top. Our next conversion factor then would have to have pints on the bottom to get rid of pints and pounds on the top to get us into pounds. So 1.25 times 1 divided by 2 times 1 divided by 1 gives us 0.625 pounds. Number 9. We have 149 centimeters and we want to convert to meters. So we need meters on top as our new unit, centimeters on the bottom to cancel centimeters away, and that would be 1 meter over 100 centimeters. 149 times 1 divided by 100 is 1.49. That's meters. You can also, just since we're dividing by 100, move the decimal point 2 to the left and get 1.49 that way. Number 10, 1.625 meters to millimeters. We're going to need millimeters on top as our new units. We're going to need meters on the bottom to cancel those away. So that would be 1,000 millimeters over 1 meter. We multiply 1.625 times 1,000. We divide by 1. That gives us 1,625 millimeters. Since we're multiplying by 1,000, we could also move the decimal point 3 spaces to the right and get 1,625 that way. Number 11, 0.35 kilograms to grams. We need kilograms on the bottom to cancel them away, grams on top to be our new unit. That's going to be 1,000 grams over 1 kilogram. Multiply 0.35 times 1,000 divided by 1. We get 350 grams. Again, since we're multiplying by 1,000, you could also just move the decimal point 3 spaces to the right and get 350 that way. Number 12, 978 milliliters to liters. We're going to need milliliters on the bottom to cancel those away. We're going to need liters on top to be our new units. That's going to be 1 liter over 1,000 milliliters. Multiply 978 times 1 divided by 1,000, and we get 0.978 liters. Once again, since we're just dividing by 1,000, we can move the decimal point 3 spaces to the left and get 0.978 that way. Number 13, 12 grams to kilograms. We want to cancel grams away, so grams has to go on the bottom. We want kilograms to be our new units, so kilograms has to go on top. That conversion factor is going to be 1 kilogram over 1,000 grams. 12 times 1 divided by 1,000 gives us 0.012 kilograms. Since we're just dividing by 1,000, we can move the decimal point 3 to the left and get 0.012 that way as well. Number 14, 0.5 kilometers or kilometers to centimeters. We're going to use meters as the common goal here. We're going to go kilometers to meters. We're going to go meters to centimeters. I keep saying kilometers, but you know, kilometers. So first, to get us into meters, we would need meters on top and kilometers on the bottom to cancel kilometers away. Then to get rid of meters and leave us with centimeters, we would need meters on the bottom and centimeters on top. So our first conversion factor is going to be 1,000 meters over 1 kilometer. Our second conversion factor is going to be 100 centimeters over 1 meter. First kilometers cancel, then meters cancel, leaving us with centimeters. So 0.5 times 1,000 divided by 1 times 100 divided by 1 gives us 50,000 centimeters. Here, since we're multiplying by 1,000 and then multiplying by 100, we could also move the decimal place 3 spaces to the right, followed by another 2 spaces to the right, for a total of 5 spaces to the right, and get 50,000 that way. We're going to do number 15 similarly. We have 9,000 milligrams and we need to go to kilograms. You know, it's funny, we pronounce it kilometers, but we don't pronounce it kilograms. Anyway, we're going to use grams as the common unit here. Convert to grams first, then to kilograms. To get milligrams into grams, we would need milligrams on the bottom and grams on top. And then to get grams into kilograms, we would need to cancel grams away with grams on the bottom and have kilograms on top. The math would be 9,000 times 1 divided by 1,000 times 1 divided by 1,000. That gives us 0.009. And then milligrams canceled, and then grams canceled, and left us with kilograms. Since we're dividing by 1,000 and then dividing by 1,000 again, we could also move the decimal point 3 spaces to the left, and then another 3 spaces to the left, and get 0.009 that way. In number 16, we want to go 48 feet to meters. We're going from US customary to SI. The conversion factor we have with SI and US customary when it comes to distance is this 0.9144 meters per yard. That means we need to get our feet into yards first before we could use it. To get feet to yards, we would have to have feet on the bottom and yards on top. That's going to be 1 yard over 3 feet. And then to get yards to meters, we could use our 0.9144 meters over 1 yard. Meters on the top, yards on the bottom. First, the feet cancel, then the yards cancel, leaving us with meters. The math would be 48 times 1 divided by 3 times 0.9144 divided by 1, and we get 14.6304. And again, anything that's times 1 or divided by 1, you can skip over. You could just do 48 divided by 3 times 0.9144. You'll get the same answer. Times 1 divided by 1, they do not make a difference. They do not change the value. Number 17, 7.72 liters to quarts. We have a quarts to liters conversion. That is 1 quart is approximately 0.946 liters. So we're going to use that. We need to set it up with liters on the bottom to cancel liters away. Quarts on top to be our new units. 7.72 times 1 divided by 0.946 gives us approximately 8.16 liters. The reason number 16 was exact and number 17 was approximate has to do with the fact that the meters to yards conversion was an exact value, but the quarts to liters conversion was an approximate value. Number 18, 15 pints per day to gallons per day. The per day part doesn't change, so we're going to keep days as our bottom. We're not going to cancel that out anywhere with days on top. Days on bottom is going to stay days on bottom. We do need to get from pints to gallons, though. We know a quarts to gallon conversion. 1 gallon is 4 quarts. So let's do pints to quarts first. Get everything in quarts and then get everything in gallons. So 15 pints over 1 day is our starting point. We want to cancel pints away, so we need pints on the bottom. We're going to quarts first, so quarts on top. 1 quart over 2 pints. Then we want to cancel quarts away and leave ourselves with gallons. So quarts on the bottom, gallons on top. That's a 1 gallon over 4 quarts. The unit that's left over on the bottom is the days that we started with. The units we have on top now are gallons, so we are in gallons per day like we want. Doing the math, 15 divided by 1 times 1 divided by 2 times 1 divided by 4 gives us 1.875. And once again, you could have just done 15 divided by 2 divided by 4 and get the same answer. Number 19, we have $1.25 or $1.25 per quart to dollars per gallon. Here, the dollars on top, we don't want to change that unit, so we're never going to cancel with dollars on the bottom. But we want to change quarts on the bottom to gallons on the bottom. So we need quarts to cancel. Quarts has to go on top. And we want to replace that with gallons on the bottom. So the conversion factor we're going to use is 4 quarts over 1 gallon. Quarts cancels, leaving us with dollars on top, gallons on the bottom like we need. The math would be 1.25 divided by 1 times 4 divided by 1, which gives us $5 per gallon. Number 20, 75 miles per hour to miles per minute. We're starting with 75 miles over 1 hour. We're keeping miles as the units on top, so we're never going to cancel with miles on the bottom, but we do need to change hours on the bottom to minutes on the bottom. So we're going to cancel with hours on top, minutes on the bottom. That conversion factor is 1 hour over 60 minutes. Hours cancel, leaving us with miles on top and minutes on the bottom like we need. 75 divided by 1 times 1 divided by 60 gives us 1.25 miles per minute. Number 21, 57 miles per hour to kilometers per hour. We're going to have to use quite a few conversions to get there, but we're only changing miles to kilometers. We have hours on the bottom like we need. Looking at all of the unit conversions we have, the thing that gets us from US customary to SI is our conversion factor of 0.9144 meters per yard. That means we're going to have to use meters and yards to get to kilometers from miles. To get from miles to yards, we're going to have to use our yards to feet conversion because we have feet to miles. So we have to go from miles to feet to yards to meters, then to kilometers. So it's a lot of conversion factors. But in order to figure out how to go, we just need to be able to cancel something and get to something else. So to get rid of miles, we need miles on the bottom. That's going to be feet on top, 5,280 feet over 1 mile. Miles cancels, leaving us in feet. To get from feet to yards, we would need feet on the bottom to cancel and the yards on top. That's going to be 1 yard over 3 feet. Then we could use our magical conversion of 0.9144 meters to 1 yard, being sure that yards are on the bottom to cancel yards away, getting us to meters. Finally, meters to kilometers needs to have meters on the bottom to cancel away, kilometers on top. That's 1 kilometer over 1,000 meters. So the math here is 57 divided by 1 times 5,280 divided by 1 times 1 divided by 3 times 0.9144 divided by 1 times 1 divided by 1,000. And that's approximately 91.713 kilometers per hour. So hours stayed on the bottom, didn't get canceled away. We converted the top from miles to feet to yards to meters to kilometers. If you wanted to do it without all those divided by 1 times 1s, you would have done 57 times 5,280 divided by 3 times 0.9144 divided by 1,000. That would have also given you 91.713. Number 22. We have 42 miles per hour and we want to go to feet per second. So we need to change miles on the top to feet, and we need to change hours on the bottom to seconds. Let's take care of miles to feet first. We have a feet to miles conversion. So miles on the bottom, feet on top cancels miles away and leaves us with feet. That conversion factor is 5,280 feet over 1 mile. Then we need to get rid of hours on the bottom. We know how many minutes are in an hour. Hours needs to go on top to cancel with hours on the bottom. Hours cancel, leaving us with minutes on the bottom. That's going to be 1 hour over 60 minutes. Then we can convert minutes to seconds. We would need minutes on top and seconds on the bottom to cancel minutes away and leave us with seconds on the bottom. That's going to be 1 minute over 60 seconds. So miles canceled, leaving us with feet on top. Hours canceled and minutes canceled, leaving us with seconds on the bottom. 42 divided by 1 times 5,280 divided by 1 times 1 divided by 60 times 1 divided by 60 gives us 61.6 feet per second. Okay, moving into problem solving. Number 23 says that in the chapter opener, the Harvard Bridge is measured to be 364.4 smoots in length. How long is the Harvard Bridge in feet and inches? Now, I could just say that 1 smoot is 5 foot 7 inches, but let's get some context to that and review the chapter opener real quick. The beginning of chapter 5 says, the Harvard Bridge, connecting Boston and Cambridge, Massachusetts, has distance markings measured using smoots, a unique unit of measurement created as part of a fraternity prank at MIT in 1958. 1 smoot is approximately 5 feet and 7 inches in length, exactly the height of Oliver R. Smoot, one of the fraternity's newest members at the time. His fraternity brothers were tasked with using his body as a measuring stick to find the length of the bridge. The chalk marking that they used to track their progress across the bridge are now repainted every year. The Harvard Bridge measures 364.4 smoots, plus or minus 1 ear. So that's what a smoot is. It's 5 foot 7 inches. So we have the Harvard Bridge is measured to be 364.4 smoots, and we want this in feet and inches. So we already have some inches. Let's convert it all to inches. So 1 smoot in inches, we'll take the 5 feet part of it first. We want to get rid of feet and put that in inches. So feet on the bottom, inches on top. Feet cancel away. 5 times 12 divided by 1 gives us 60 inches. Add the 7 inches, and we find that 1 smoot is 67 inches. Now, we're going to convert 364.4 smoots into inches. We need smoots on the bottom and inches on top, so smoots cancels away. Inches on the top means we're going to convert into inches. 364.4 times 67 divided by 1 gives us 24,414.8 inches. And if we convert that to feet, because we need it in feet and inches, we would need inches on the bottom and feet on top. So 24,414.8 inches times 1 foot over 12 inches. Inches cancels away, leaving us with feet. 24,414.8 times 1 divided by 12 is 2,034.567 feet. So we have the feet part of it now, 2,034. We need the inches. Well, 2,034 feet in inches would be 2,034 feet times 12 inches over 1 foot. Feet cancel, leaving us in inches, 24,408 inches. If we subtract that from the 24,414.8 inches, we get 6.8 inches left over as a remainder. So it's 2,034 feet and 6.8 inches. The Harvard Bridge is 2,034 feet, 6.8 inches. That was a weird conversion because first we were dealing with these imaginary smoots. It's not imaginary, it's just very rare. But we also needed to find the remainder of inches in order to get feet and inches instead of just feet. Number 24. In number 24, we're told Carl is building a platform to hold a rain barrel in place. If the barrel itself weighs 23 pounds and the barrel can hold 35 gallons of water, how much weight will the platform need to support? Well, the platform is going to need to support the weight of the water plus the weight of the barrel. We're told the barrel is 23 pounds, but we need to find the weight of the water. This is going to come down to the fact that, once again, a pint's a pound the world round, which means in order to get to pounds, we need to get to pints first. So we're going to convert gallons all the way to pints using quarts and then pints. So we start with 35 gallons, and we need to multiply by the conversion factor that has gallons on the bottom and quarts on top. That's 4 quarts over 1 gallon. Gallons cancels, and we're in quarts. Then we need quarts on the bottom and pints on top to cancel quarts away and get us to pints. That's 2 pints over 1 quart. Then finally, we can use pounds on top and pints on the bottom with our 1 pound is 1 pint conversion. That'll cancel pints away, leave us with pounds. 35 times 4 divided by 1 times 2 divided by 1 times 1 divided by 1 gives us 280 pounds for the weight of the water. If we take the weight of the water and add the weight of the barrel, that's 280 pounds plus 23 pounds. That means the platform needs to support 303 pounds. In number 25, Marvin is planning to put a decorative fence around the garden depicted below. How much fencing will he need? This garden is 12 feet by 3.4 feet. Don't automatically assume we're finding area because that's what we were talking about. This is going to be the perimeter. So just because we did area most recently doesn't mean everything is going to be area. We need to be able to determine, do we need perimeter or do we need area? Here we need the perimeter because it's the distance around. So we add the sides. Let's start in the bottom left. 12 plus 3.4 plus 12 plus 3.4 gives us 30.8 feet. In number 26, Dana intends to wrap a length of chain around a barrel to anchor it to the fence post. Would it be cheaper for Dana to use the chain that sells for 20 cents per inch or the one that sells for $6.49 per meter? We must change one unit to match the other and then compare in order to be able to figure this out. So we either need them both to be in inches or both to be in meters. Let's change the $6.49 per meter into dollars per inch. In order to do that, we need to get from SI units to US customary units. So meters has to cancel. Meters is going to go on top. Yards has to go on the bottom because we have a meters to yards conversion. And that conversion is 0.9144 meters over 1 yard. So now we're in dollars per yard. To get our way into inches, next we'll go from yards to feet. Yards on top, feet on the bottom to cancel out the yards from the bottom. Change it to feet. That's going to be 1 yard over 3 feet. Then we can go from feet to inches. Feet on top to cancel out the feet on the bottom. Inches on the bottom to make us have what we need, which is inches on the bottom. That's 1 foot over 12 inches. Doing the math, 6.49 divided by 1 times 0.9144 divided by 1 times 1 divided by 3 times 1 divided by 12 gives us $0.16 per inch, or 16 cents per inch. So the $6.49 per meter is 16 cents per inch, and that makes it cheaper than the 20 cents per inch. So the $6.49 per meter is cheaper. Number 27. One pitching machine is calibrated to throw a baseball at 75 miles per hour. Another will throw the ball at 35 meters per second. Which pitching machine throws the ball faster? So again, we have to change one unit to match the other and then compare. Let's change miles per hour into meters per second. So first, let's take care of changing miles to meters, and then we'll take care of hours to seconds. What do we have conversion-wise for miles? Well, we know how many feet are in a mile. So let's make that change. Miles on the bottom to cancel miles on top, feet on top to change to feet per hour. That's 5,280 feet over 1 mile that we'll use. Eventually, we need to get to meters, and we know our meter conversion has to have to do with yards. So let's change feet to yards. We're going to need feet on the bottom to cancel feet on the top. Yards on top to get us into yards. That's going to be 1 yard over 3 feet. Now we can get to meters with meters on top and yards on the bottom, canceling yards away. Our conversion factor is 0.9144 meters over 1 yard. Doing the math here, we have 75 divided by 1 times 5,280 divided by 1 times 1 divided by 3 times 0.9144 divided by 1. That gives us 120,700.8 meters per hour. We need meters per second. So we need to convert hours on the bottom to seconds on the bottom. We start with our 120,700.8 meters over 1 hour. And to get hours into minutes, we would need hours on top to cancel with hours on the bottom, and minutes on the bottom to get to per minutes. That's 1 hour over 60 minutes. Then to get from per minute to per second, we need to cancel minutes from the bottom. So we use minutes on top, seconds on the bottom to get to per second. That's 1 minute over 60 seconds. Now hours canceled and minutes canceled, leaving us in meters per second like we need. So 120,700.8 divided by 1 times 1 divided by 60 times 1 divided by 60 gives us 33.528 meters per second, which is a little bit slower than 35 meters per second. So the 35 meters per second pitching machine is faster. Number 28. In number 28, we're told the speed of light in a vacuum is 670 million miles per hour. At this speed, how far will one photon of light travel in 9 seconds? So first we must find the speed per second. It's given in hours, we need it in seconds. So we start with our 670 million miles over 1 hour. And then we need to cancel hours. So hours goes on top, and our hour conversion first must go through minutes. So minutes on the bottom. That's 1 hour over 60 minutes. Then we need to cancel minutes and get it into per second. So minutes on top to cancel minutes away from the bottom, seconds on the bottom. That's 1 minute over 60 seconds. Doing this math, 670 million divided by 1 times 1 divided by 60 times 1 divided by 60 gives us 186,111.11111111111 miles per second. So then we need to account for there being 9 seconds. So we multiply what we have by 9 seconds. That's going to cancel seconds out of the bottom and just leave us with miles, which is what we want since the question asks how far, not how fast. 186,111 point a bunch of ones divided by 1 times 9 gives us 1,675,000 miles. And finally, for the 5.4 homework, number 29, Tammy's Terrific Tincture costs $14.65 per gallon to produce. How many ounces of the tincture can Tammy produce for $1.50? So we're given the price per gallon. We need to find the price per ounce. And we're going to have to use a lot of conversion factors to get there. We know how many quarts are in a gallon. We know how many pints are in a quart. We know how many cups are in a pint. We know how many ounces are in a cup. So those are the conversion factors we're going to use to get from gallons down to ounces. The thing we're trying to cancel is on the bottom, gallons. So gallons must first be on top with quarts on the bottom. That's 1 gallon over 4 quarts. Then we want to cancel quarts away. So quarts on top, and we're going to have pints on the bottom. 1 quart over 2 pints. Then we want to cancel pints away. So pints on the top to cancel pints on the bottom with cups on the bottom. Then we want to cancel away cups. By the way, that was 1 pint over 2 cups. We want to cancel cups away to get rid of cups on the bottom. So cups on top, ounces on the bottom, which is what we need on the bottom, because we want the price per ounce. That's 1 cup over 8 ounces. Gallons cancels, quarts cancels, pints cancels, cups cancels, and we have dollars per ounce like we need. Doing the math, 1465 divided by 1 times 1 divided by 4 times 1 divided by 2, times 1 divided by 2, times 1 divided by 8 gives $0.1145 per ounce. We need to account for $1.50. We want to know how many ounces we can get for $1.50. Since we want our final answer in ounces, ounces has to start on top. So we start with 1 ounce over $0.1145. Then when we multiply by the $1.50 or $1.50, dollars will cancel away, leaving us with just ounces. So 1 divided by 0.1145 times 1.5 is approximately 13.1 ounces. So Tammy can produce 13.1 ounces for $1.50. Now let's go on to the 5.5 homework. And again, for the first many, we're going to perform the indicated unit conversions, but these unit conversions are going to involve squared things. And remember, to get rid of a squared unit, we would need 2 factors of the regular unit in order to cancel. So number 1, we have 5,280 centimeters squared, or square centimeters. We need to convert to square meters. So in order to get rid of square centimeters, we would need centimeters on the bottom twice. Our conversion factor into meters would be 1 meter over 100 centimeters. And again, we need that twice. Having centimeters on the bottom twice cancels out square centimeters on top. And then having meters twice on the top gives us square meters. The math would be 5,280 times 1 divided by 100 times 1 divided by 100, which gives us 0.528 square meters. Number 2, we're starting with 0.139 square meters, and we want to convert to square millimeters. So again, to get rid of meters squared or square meters on top, we need meters on the bottom twice. And we want to get to square millimeters, which means we're going to need millimeters on the top twice. So that conversion factor we're going to use twice is 1,000 millimeters over 1 meter. Doing that twice gives us meters on the bottom twice, cancels out square meters. Also gives us millimeters times millimeters on top to get us into square millimeters. The math part of it, 0.139 times 1,000 times 1,000 again, gives us 139,000 square millimeters. Next up, number 3. We want to convert 3.27 square feet into square inches. Since we need to cancel square feet from the top, that means we're going to need feet on the bottom twice. Since we're trying to get into square inches, we're going to need inches on the top twice. So the conversion factor we're going to use twice is 12 inches over 1 foot. Feet on the bottom twice cancels square feet from the top. Inches on the top twice gives us square inches. The math would be 3.27 times 12 divided by 1 times 12 divided by 1. That's 470.88 square inches. Number 4, 225 square inches to square feet. To get rid of square inches on the top, we need inches on the bottom twice. To get to square feet, we need feet on the top twice. So inches on the bottom twice cancels out square inches. feet on the top twice gives us square feet. That conversion factor we use to get there is 1 foot over 12 inches. We use that conversion factor twice. The math would be 225 times 1 divided by 12 times 1 divided by 12, which gives us 1.5625 square feet. Number 5, 7.8 square meters to square yards. We have a conversion factor that goes from yards to meters. We're going to have to use that twice. To get rid of square meters on the top, we need meters on the bottom twice. To get to square yards, we need yards on the top twice. So the conversion factor we're going to use twice is 1 yard over 0.9144 meters. Meters on the bottom twice cancels square meters from the top. Yards on the top twice gives us square yards. The math, 7.8 times 1 divided by 0.9144 times 1 divided by 0.9144. That gives us approximately 9.33 square yards. In number 6, we have $3.58 per square foot to cost per square yards. So we're kind of doing the same thing here, just a little bit differently, because the thing we need to cancel out is on the bottom. We're keeping dollars on top, but we need to change square feet to square yards. So to get rid of square feet on the bottom, we're going to need feet on the top twice. To get to per square yard, we're going to need yards on the bottom twice. So feet and feet on top twice cancels out square feet on the bottom. Yards and yards on the bottom twice gives us square yards on the bottom. We keep dollars on top. So the math, 3.58 divided by 1 times 3 divided by 1 times 3 divided by 1 gives us 32.22. So $32.22 per square yard. In number 7, we have 48 psi to grams per square centimeter. Now you can already see we use a lot of conversion factors here, but what the heck is psi? Well, psi stands for pounds per square inch. So 48 psi is 48 pounds over 1 square inch. We need to end up with grams per square centimeter. So the pounds on top need to get converted to grams. And then the square inches on the bottom need to get converted to square centimeters. Complicating matters is the fact that to get from the US customary inches to the SI centimeters, we need to go through the yards per meter conversion. So we're going to have to get our inches to feet and then to yards, and we're going to have to get our pounds to grams. Luckily, pounds to grams isn't that bad. We have that conversion, 453.59237 grams per pound. Pounds have to go on the bottom to cancel pounds on top, leaving us with grams on top. So that's going to be the conversion factor of 453.59237 grams over 1 pound. Pounds cancels, leaving us in grams per square inch. Now, we've got to get up to yards to use the conversion factor for meters. So first, we'll do inches to feet, but we need to get rid of square inches on the bottom, which means we need inches on the top twice. We're going to use 12 inches over 1 foot twice. Inches twice on the top cancels out square inches on the bottom, leaving us with feet twice on the bottom, or square feet on the bottom. Now we need to change those square feet to square yards, so we need feet on the top twice to get rid of the square feet on the bottom, and we need yards on the bottom twice to get to square yards on the bottom. We're going to use 3 feet over 1 yard twice. Feet on the top twice cancels out square feet on the bottom, yards on the bottom twice. We are now in grams per square yard. Now we can change square yards to square meters. We would need yards on the top twice to cancel out yards squared on the bottom. We would need meters on the bottom twice to get into square meters on the bottom. Conversion factor we're going to use is 1 yard over 0.9144 meters. We use that twice. Now yards on top twice gets rid of square yards on the bottom. Meters on the bottom twice gives us square meters on the bottom. Finally, we need to go from square meters to square centimeters. So meters has to be on top twice to get rid of meters on the bottom twice, or to get rid of square meters. Centimeters needs to be on the bottom twice to give us square centimeters on the bottom. The conversion factor that we're going to use twice is 1 meter over 100 centimeters. So now meters and meters cancel out meters squared. Centimeters and centimeters on the bottom gives us square centimeters on the bottom. We are in grams per square centimeters. We can do the math now. 48 divided by 1 times 453.59237 divided by 1 times 12 divided by 1 times 12 divided by 1 times 3 divided by 1 times 3 divided by 1 times 1 divided by 0.9144 times 1 divided by 0.9144 times 1 divided by 100 times 1 divided by 100. That gives us approximately 3,374.73 grams per square centimeters. So we had a lot of conversion factors there to get where we needed. We're going to do similar in number 8, where we're converting 220 kilograms per square meter to PSI. Again, that's pounds per square inch. So kilograms needs to go to pounds. Square meters needs to go to square inches. To get from kilograms to pounds, we need to go through grams. We know that 1,000 grams is 1 kilogram. So we need to put the kilograms on the bottom to cancel out kilograms from the top. That's 1,000 grams over 1 kilogram. Kilograms cancel, leaving us with grams. We need to go to pounds. We have the pounds to grams conversion. Grams has to go on the bottom to cancel out grams on top. Pounds has to go on top to give us pounds on top. That conversion factor would be 1 pound over 453.59237 grams. So now we're in pounds per meter squared. We need pounds per square inch. We need to get from meters to inches. We have to go through meters to yards first. So meters has to be on top twice to cancel out square meters on the bottom. Conversion factor we're going to use is 0.9144 meters per 1 yard. And we use that twice. Now, meters on top twice, has canceled out square meters on the bottom, and we're left with yards on the bottom twice, or square yards. We need to go square yards to square feet, and then square feet to square inches. So to get rid of square yards on the bottom, we need yards on top twice. We can convert to square feet on the bottom by using feet on the bottom twice. Conversion factor we're using then is 1 yard over 3 feet twice. Now we are in pounds per square foot. To get us to pounds per square inches, we need to get rid of square feet on the bottom. We do that with feet on the top twice. To get into square inches on the bottom, we need inches on the bottom twice. The conversion factor we'll be using twice is 1 foot over 12 inches. So now we're in square inches on the bottom. Square feet have canceled. We're in pounds per square inch. We can do the math. 220 divided by 1 times 1,000 divided by 1 times 1 divided by 453.59237 times 0.9144 divided by 1 times 0.9144 divided by 1 times 1 divided by 3 times 1 divided by 3 times 1 divided by 12 times 1 divided by 12. And that gives us approximately 0.313 PSI, pounds per square inch. So it's a good thing there weren't 22 of those like in the last section. We get to move on to something else, something a little bit more fun. In number 9, we want to find the area of the given figure. A circle with circumference of 40 inches. In order to find the area, we're going to need to find the radius first. We know that circumference is pi times the diameter, so let's set that up. The circumference is 40. For pi, we're going to use 3.14159. So we have 40 equals 3.14159 times d. To get d by itself, we divide both sides by 3.14159, and 40 divided by 3.14159 is 12.732. So that's approximately our diameter. Since the diameter is twice the radius, we divide the diameter by 2, and we get that the radius is 6.366, and we use that for the area calculation. Area equals pi times the radius squared. Area equals 3.14159 times the square of 6.366. When we square 6.366, we get 40.525956. Multiplying that by 3.14159, we get 127.3, and that would be in square inches. Since our original measurement for circumference was regular inches, area is going to be square inches. Number 10, find the area of the given figure. Here we have a trapezoid. Remember, for our trapezoid, we take the average of the bases times the height, or base 1 plus base 2 times 1/2. The 3.5 centimeter side and the 5 centimeter side, we don't need that information. We just need the bases and the height. So 1/2 of base 1 plus base 2 is 1/2 of 5 plus 11 is 1/2 of 16 is 8. Multiply that by the height, which was 3, and we get 24 square centimeters. Again, that's square centimeters because this is area and our measurements were in regular centimeters. Number 11, we want to find the length of the indicated line segment. That's our double question mark here. And we're told that the rectangle has an area of 10.2 square meters. We know that area is length times width. Our length is 6.0 meters. Our width is unknown, so we'll call that x, plugging in what we know. A would be 10.2. L would be 6.0. W is our unknown. W is x. Or you can leave it as W. That's fine too. To get the x, the unknown, the variable by itself, we need to divide both sides by 6.0. 10.2 divided by 6.0 gives us 1.7. So 1.7 meters must be the missing side. Number 12, we want to find the length of the indicated line segment, our double question mark. In this case, it looks like we're looking for the diameter of a circle. We can find the diameter if we knew the radius. And since we have an area, we can find the radius. So area equals pi times the radius squared. The radius is unknown, but we know the area, and we know pi. So 433.75 equals 3.14159 r squared. To get r by itself, we have to start by getting r squared by itself. So divide both sides by 3.14159. And 433.75 divided by 3.14159 is 138.067. That's r squared. To get r, we would need to take the square root of both sides. The square root of 138.067 is approximately 11.75. That would be the radius. That would be half of what we need. So double the radius and get the diameter. 2 times 11.75 is 23.5. Since the area was in square inches, the length will be in regular inches, 23.5 inches. Number 13, find the length of the indicated line segment. Looks like we're looking for a diagonal of a square. And we know it's a square because we're told it's a square. The square below has an area of 5.25 square feet. So area of a square is the same as area of a rectangle, length times width. But since a square has all sides being the same, length times width would be the same as side times side, which is side squared. So the area of 5.25 equals the side squared. If we take the square root of both sides, we get that a side of this square is approximately 2.291 feet. We found the sides, but how does that help us find the diagonal? Well, the diagonal would be a hypotenuse of a right triangle. The two legs would have the side length, and we're looking for the hypotenuse length. We would use the Pythagorean theorem for that. A squared plus b squared equals c squared. So plugging in for the two legs, A and B, we plug in 2.291. So we have 2.291 squared plus 2.291 squared equals c squared. Squaring 2.291 twice, we get 5.248681 plus 5.248681 equals c squared. Adding those together, we get 10.497362 is c squared. And taking the square root of both sides, we find that c, the hypotenuse, the diagonal of this square that we're looking for, is approximately 3.24 feet. In number 14, we're given this figure and we're asked to find the area of the depicted figure and round to the nearest hundredth if necessary. Now, I'm showing that there are two ways that we can split this figure up. We can either draw a line right here and split it into a big rectangle and a square. Or we can draw a line here and split it into a long rectangle and a short rectangle. So we can have a rectangle and a square, or a long rectangle and a short rectangle. Either way, we would need to find the areas of both and then add them together. So if you pick the rectangle and a square, the rectangle would be 8 by 5, and 8 times 5 is 40. The square would be 2 by 2, and 2 times 2 is 4. So the 40 plus the 4 would give us a total area of 44 square feet. Or if you use the long rectangle and the short rectangle, the long rectangle would be 10 by 2, and 10 times 2 is 20. The short rectangle would be 8 by 3, and 8 times 3 is 24. Adding those up, 20 plus 24 also gives you the correct answer of 44 square feet. Number 15, we have this figure here. We're asked to find the area, and again, round to the nearest hundredth if necessary. We can split this into a triangle and a rectangle, so the total area will be the area of the triangle plus the area of the rectangle. The formula for area of the triangle is 1/2 base times height. The base would be 5 inches. The height would be 4 inches. So it would be 1/2 5 times 4, which is 1/2 times 20, which is 10 for the area of the triangle. For the rectangle, we would have length times width. That would be 5 times 6, which is 30. So add together the area of the triangle 10 with the area of the rectangle 30, and we get a total area of 40 square inches. Number 16. We're going to have a lot of steps here. But again, we want to find the area of the depicted figure. And for 16, we're finding the area of the outer ring. So let's think about this. We see that this is split here. We can imagine that we could also split on the right side of the figure the same way, giving us the left half of a circle and the right half of a circle. We have this twice as a big figure, the big round ring, and a small figure, the small round ring. In order to get just the outer ring, we would have to take the big figure's area and subtract the small figure's area. So we got to deal with the big figure first. Our goal is going to be a complete circle, half and half, plus a rectangle. The big circle and the big rectangle. So in the big figure, the circle would have a diameter of these three lengths added together, 18 plus 43 plus 18. So we'd have a diameter of 79 inches. Half of that would be the radius of the big circle, and the radius would be half of 79, or 39.5 inches. Now that we have the radius of the big circle, we can find the area of the big circle using area equals pi times the radius squared. Area would be 3.14159 times the square of 39.5. 39.5 squared is 1,560.25. Times 3.14159 gives us approximately 4901.67, 4,901.67 square inches. So that's the area of the big circle. Let's set that aside for now. We need to find the area of the big rectangle. So for the big rectangle, one side is going to be the same as the diameter of the circle, 18 plus 43 plus 18, that was 79 inches. And we can see the other length is 76 inches. So area equals length times width. Area is going to be 76 times 79, which gives us 6,004 square inches. So 6,004 square inches is the area of the big rectangle. The area of the big circle was 4,901.67. Adding those together, the big figure has an area of 10,905.67 square inches. We're going to set that aside for now. We're going to subtract the area of the smaller figure from that to get the outer ring. But in order to get the area of the smaller figure, we again need a circle plus a rectangle's area. It's going to be the small circle plus the small rectangle. So the small circle has a diameter of 43 inches. Half of that for the radius would be a radius of 43 divided by 2, or 21.5 inches. So the area of the smaller circle is pi times the radius squared. That's 3.14159 times the square of 21.5. And 21.5 squared is 462.25. Times 3.14159 gives us an area of the small circle of 1,452.20. We need the area of the smaller rectangle. The length is still 76, but the height of the smaller rectangle is 43. Length times width, 76 times 43, gives us 3,068 square inches. So for the smaller figure, the small circle plus the small rectangle is 1,452.20 plus 3,268. The small figure has an area of 4,720.20 square inches. Finally, the big figure minus the smaller figure is just going to give us the outer ring that we want. So 10,905.67 minus 4,720.20 gives us 6,185.47 square inches. So all of that to find the area of the outer ring. Number 17. We want to find the area of the wall, not including the window or the door. So we would need to find the area of the total wall and then subtract the area of the door and subtract the area of the window. In other words, the area of the big rectangle minus the area of the little rectangle minus the area of the circle. So the area of the big rectangle, we have a width of 8 and a length of 2 plus 3 plus 8, or 13 feet. So 13 feet times 8 feet gives us a big rectangle area of 104 square feet. The little rectangle has an area of 3 feet times 7 feet, or 21 square feet. And then for the circle, we're given the diameter. We need the radius, which is half of the diameter. Half of 3 feet would be 1.5 feet. Plugging that into the area formula, pi times the radius squared, we would have 3.14159 times the square of 1.5. 1.5 squared is 2.25 times 3.14159 gives us 7.07 square feet for the area of the circle. So now execute our plan. The big rectangle minus the little rectangle minus the circle is 104 minus 21 minus 7.07, which gives us 75.93 square feet. Number 18. A goat farmer is planning to build a square pen for his pygmy goats. If the farmer uses 75 feet of fencing to build the pen, how much area will the goats have to roam inside the pen? We're told to round to the nearest tenth of a square foot if necessary. So we're using 75 feet of fencing to build the square pen. That is a perimeter. And for a square, the perimeter would be side plus side plus side plus side, because all the sides would be the same. Side plus side plus side plus side is 4 times the side length, or 4s. So the perimeter equals 4s. The perimeter is 75, so 75 equals 4s. Divide both sides by 4 to get s by itself. 75 divided by 4 is 18.75. So we have a side length of 18.75. We need the area. The area is length times width, or side times side, which is side squared. And when we square 18.75, we get 351.6 square feet. Number 19. Remembering that a circle gives the best perimeter to area ratio, the pygmy goat farmer from the previous exercise instead wants to use his 75 feet of fencing to build a circular pen. How much area will the goats have to roam inside the pen? Round to the nearest tenth of a square foot if necessary. So now the 75 feet is still a perimeter, but it's technically a circumference because it's of a circle, not a square. So the circumference is 75. We can use the circumference formula, C equals pi d, and plug things in and get 75 equals 3.14159 times d. Dividing both sides by 3.14159 gets d by itself. 75 divided by 3.14159 is approximately 23.873. as the diameter of the circle. To find area, we need the radius, so we need to divide the diameter by 2. The radius then would be 23.873 divided by 2, or 11.9365. Plug that into the area formula, pi times the radius squared. Area would be 3.14159 times the square of 11.9365. When we square 11.9365, we get 142.48003225. Multiplying that by 3.14159 and rounding to the nearest tenth of a square foot, we get 447.6 square feet. Number 20. Reconsidering, our goat farmer realizes that he needs to build a larger pen that will give the goats 750 square feet of space to roam. How much fencing will he need to build this larger circular pen? Again, we're going to round to the nearest tenth of a foot if necessary. We have our area formula. Area equals pi times the radius squared. And we want an area of 750 square feet. So we plug 750 in for A. We use 3.14159 for pi. That gives us 750 equals 3.14159 times r squared. To get r squared by itself, we need to divide both sides by 3.14159. 750 divided by 3.14159 gives us 238.733. That is our approximation for r squared. To get r, we're going to need to take the square root of both sides. And the square root of 238.733 is 15.451. So let's take a moment and see where we are. We now have the radius of 15.451 feet. We need to know how much fencing we need to build the circular pen. That means we need to know the circumference of the circle that has the radius of 15.451 feet. In order to find circumference, we need the diameter. The diameter is 2 times the radius, which is 2 times 15.451, which is 30.902. So plugging into circumference equals pi times diameter, the circumference would be 3.14159 times 30.902. And that rounded to the nearest tenth of a foot is 97.1 feet. So he'll need 97.1 feet of fencing. On this slide, we have both numbers 21 and 22. 21 says, one synthetic fabric is sold at $3.49 per square foot. How much will it cost to purchase a rectangle of this fabric, which measures 9 feet by 12 feet? So first we need to find the area, that is 9 feet by 12 feet. Area equals length times width. And 9 times 12 gives us 108 square feet. So we're purchasing 108 square feet of material at $3.49 per square foot. If we multiply these together, square feet will cancel, leaving us with just dollars. $3.49 per square foot times 108 square feet gives us $376.92. Fabric is expensive, yo. Number 22. At a depth of 80 feet, water pressure is 50 pounds per square inch. At this depth, how much weight of water is pushing on an observation window which measures 15 inches by 8 inches? So again, we need the area. The area is the length times the width. That's 15 inches times 8 inches, which is 120 square inches. We have a conversion. Our water pressure is 50 pounds per square inch. If we multiply 50 pounds per square inch by 120 square inches will cancel, leaving us with pounds, which is what we want. We want the weight of the water. 50 pounds per square inch times 120 square inches gives us 6,000 pounds. Some quick mental math tells me that that's 3 tons of water pressure, because a ton is 2,000 pounds. Number 23. One brand of fertilizer is advertised that each bag can cover 20 square feet of garden. The fencing around Kara's garden is depicted below. How many bags of this fertilizer will Kara need to purchase in order to fertilize her entire garden? So we can split this figure, as we see here, into a rectangle plus a triangle. The area of the rectangle would be length times width, 8 times 6, which is 48. The area of the triangle, well, if the whole distance of the figure is 16 and the part that goes to the square is 6, we can subtract 16 minus 6 and get 10 for one side of the triangle. We'll call that the base. The height of the triangle is 8. So 1/2 base times height would be 1/2 times 10 times 8, which is 1/2 times 80, which is 40. Adding together the 48 square feet of the rectangle and the 40 square feet of the triangle, we get a total area of 88 square feet. Now, one bag per 20 square feet is what we're told. We can multiply that by 88 square feet, and square feet will cancel, giving us bags. 1 divided by 20 times 88 gives us 4.4 bags. Since we can't buy 4/10 of a bag, we round up no matter what to cover the decimal part. And we'll need to purchase 5 bags of fertilizer to fertilize this entire garden. Number 24. This figure sure looks familiar. Earlier, we saw something like this, and we wanted to find the area of the outer ring. 24 says, Lenny is hiring a company to refinish the cement walkway around his swimming pool. The pool has straight sides and a semicircle finish on either side, and the walkway is 42 inches wide, as depicted below. That means, just like before, the outer ring is what we're interested in. The outer ring here is the walkway. If the company charges $4.15 per square foot, how much will it cost for Lenny to have this project completed? So first we have to find the area of the outer ring, then we have to find the cost. Notice 2 of our measurements are given in feet, but the other 2 are given in inches. We should convert one to the other, and in the interest of not having a huge number for 16 feet converted to inches, we're going to go ahead and convert 42 inches to feet. So 42 inches times 1 foot over 12 inches cancels inches away and leaves us in feet. 42 times 1 divided by 12 gives us 3.5 feet. So where we see 42 inches, we're going to replace that with a note of 3.5 feet. We have to follow the same steps for area that we did in the prior problem. We can split the two semicircles off to create a full circle, which leaves a rectangle. And we have this as both a big figure and a small figure. To get the walkway, to get the outer ring, we would subtract the smaller figure's area from the bigger figure's area. So for the big figure, our goal is the area of the circle plus the area of the rectangle. For the circle, we can find that the diameter is 3.5 feet plus 8 plus 3.5 feet. That's a diameter all the way across of 15 feet. For the area calculation, we would need the radius, though. Half of the diameter gives us the radius. Half of 15 is 7.5 feet. So the area is pi times the radius squared. That's 3.14159 times the square of 7.5. And 7.5 squared is 56.25. 56.25 times 3.14159 gives us 176.714 square feet. That is just the big circle. Now we need to find the area of the big rectangle. For the rectangle, once again, one of the sides is going to be 3.5 feet plus 8 plus 3.5 feet. That gives us 15 feet for a width, and we have 16 feet for the length. Length times width then would be 16 feet times 15 feet, which is 240 square feet for the area of the big rectangle. So for the big figure, the big circle was 176.714 square feet. The big rectangle was 240 square feet. That gives us an area for the big figure of 416.714 square feet. Now on to the smaller figure. Circle first, we can see that the diameter of the small circle is 8 feet, so the radius would be half of that. It would be 4 feet. Area of the small circle is going to be pi times the radius squared. That's 3.14159 times the square of 4. 4 squared is 16. 16 times 3.14159 is 50.265 square feet. Now for the little rectangle, area is length times width. It's going to be 8 times 16, or 128 square feet. So for the smaller figure, it's the small circle plus the small rectangle. That's 50.27 plus 128, or 178.27 square feet. So that's the area of the smaller figure. Bring back the area of the big figure and subtract the area of the small figure. 416.714 minus 178.265 gives us an outer ring area of 238.449 square feet. We were told that the company charges $4.15 per square feet, per square foot. So $4.15 per 1 square foot times 238.449 square feet. Square feet will cancel, leaving us with dollars like we want. How much will it cost? 4.15 divided by 1 times 238.449 gives us $989.56. That is the last of the homework. Thank you so much for all of your attention during this course.